Hello, I hope you guys can hear me. Let me set up my chat. So, we are going to continue studying derivatives. I think this stream I will start studying trigonometric derivatives, but I will do some questions first. Okay, let me change to full screen. Okay, so I was doing section 3.3 exercises. Let me just show the contents. So I was doing differentiation rules. I think I'll do questions of this one and then these two chapters. I want more short form questions, not the ones that take too long. For the following exercises, find the equation of the tangent line dx to the graph of the given function at the indicated point. Okay, I don't want to use a graphing calculator. I have the answer key open as well. Okay, let's do this one. Find the derivative of h of x. Oops. And this is for my thumbnail. Okay. I think I'll turn on the grid. Okay. Question 123. So, h is x cubed times f of x. So the derivative be the derivative of the first times the second. And then plus this times the derivative of f of x. Next one. 125 h of x is equal to 3 f of x over g of x plus 2. So the derivative is low d high minus high d low upon, so all this upon bottom squared. Let's see if this is correct. Okay. Okay, the first one is correct. Okay, minus. Okay, all right. I think I'll do a few more and then go to the next chapter. What's this? So, fine. Let's find the derivative. Is equal to derivative of the first times the second plus the first times the derivative of the second. And erase. Okay. How are you supposed to find this? Wait. Okay, we have to use this. So, h1 is equal to derivative of the first times the second plus the first times the derivative of the second. So, when it's at 1, the derivative is minus 2 divided by plus 2. Okay, so negative 1. And g of 1 is 1 plus it with f of 1 is 3, and then the derivative is positive 1. So 3 minus 1, 2. Now let's do part B. Derivative of the first times the second plus the first times the derivative of the second. Now this is 3 and 2.5. 3 and 2.5. Here it's 0 and undefined, so it's not possible. I'll do error. Now h4. Derivative of the first times the second plus the first times the derivative of the second. 4. So 2 and 2.5. 2 and 2.5. But the slope is 0. Over here it's a positive 1. So this is positive 1. This is 0, so it's 2.5. 131. 2 does not exist. 2.5. Good. Next one. Let's go to the next chapter. Derivatives as rates of change. The average rate of change of a function f over that's same interval, which is this one, is the ratio of the amount of change over that interval to the corresponding change in the x values, is given by this. So f of a plus h minus f of a, all that divided by h. So we already know what the derivative is, and this gives us this formula. For small enough values of h, the derivative is approximately equal to f of a plus h minus f of a divided by h. Okay, I can write this f of a plus h is equal to h plus f. Is this correct? Yes, it is. Estimating the value of a function. If f of 3 is 2 and this is 5, estimate f of 3.2. So, hold on. So using the above formula, I can say f of 3.2, 0.2, 5, 2. I have a calculator with me. This is 3. Let's check. Yes. Interpreting the relationship between v of t and a of t. A particle moves along the coordinate axis in the positive direction to the right. Its position at time t is given by s of t is t cubed minus t minus 4t plus 2. Find v of 1 and a of 1 and use these values to answer the following question. Is the particle moving from left to right or from right to left? Is the particle speeding up or slowing down? So, oops. Okay. So, derivative of this would be yeah 3t squared minus 4, and the double derivative would be 6t. So then at 1 it would be 3 minus 4. So this at 1 would be 6. So it's speeding up, but it's going in the negative direction, which is The positive direction is to the right. The negative direction is to the left. Okay. Exercises. Use the following exercises. The given functions represent the position of a particle traveling along a horizontal line. Find the velocity and acceleration function. Determine the time intervals when the object is slowing down or speeding up. Okay, there are a lot of questions. Is it all for particles? Like for slowing down and speeding up? I think this one would be, B would be a little tough. Okay. Copy. So. 151. We have this. Let's just write the derivative straight away. So the derivative is 2 times 3 is 6, 30, 36. Now what? Then the double derivative is 12 minus 12t minus 30. Now what? Okay, determine the time intervals when the object is slowing down or speeding up. So we have to use this function. This is 12t minus 30. It's a positive gradient. So it's always speeding up. Always speeding up. Model rocket is fired vertically upwards from the ground. The distance at the speed that the rocket travels from the ground after t seconds is given by s of t is minus 16 squared plus 560 t. Find the velocity of the rocket 3 seconds after being fired. Find the acceleration. Okay, so we have s of t is minus 16 squared plus 560 t. Let's just erase this. 560 t. Okay, now let's find the derivative. 32 t plus 560. Find the velocity of the rocket 3 seconds after being fired. And then the acceleration. So I just have to plug in 3 in both of these. So s of t, s of 3, and then s3. This will be minus 32. A calculator next to me. Times 464. Let's see the answer. for A, isn't the acceleration always... Oh, oops. I just saw the gradient. This is wrong. Okay, these two are correct. As for this, we are just checking at what point it's positive and at what point it's negative. So, wait. I think if I do t minus 30, when is it positive? So t is 30 over 12 and 2.5. When t is more than 2.5, this is more than 0. Hold on, I don't understand. Speeds up, slows down. It's a straight, the acceleration is a straight line. Zero to 2 it slows down. Between 2 to 2.5 it speeds up. None of this makes sense. Maybe if in the comments someone can explain. Okay, next one. The position function is this. S is in feet and T is in second. T is equal to 0 represent the time at which the back of the car is at the garage door. Determine the velocity. Okay. So S, the derivative is 2t minus 3. And the acceleration is 2. Determine the velocity of the car when S of t is 0. Hold on. When S of t is 0, you have to figure out at what time this is. It's the quadratic formula. T is equal to minus b plus minus b square minus 4ac 0.2a I have a calculator with me. 9 plus 16. So it's minus 5 or plus 5. Plus 4. D has to be positive, right? So velocity at t is equal to 4 is 2 times 4 is 8 minus 3 5. So this one is 5 and s of t is 14. So this is for A. For B it's 14, but I'm subtracting it from both sides. So for B, plus minus b squared minus 4 times a times c. Four times 18 is 72. Then plus 9. Okay, I got 9. Got 3. Wait. Shouldn't this be higher? It is higher. 6. Let's see the answer. Imagine it's wrong. 155. This is 9. Where did I? 9. 4 times 18. 81. Root 81 is 9 plus 3. It is 6. Oh, I forgot to plug it in here. So 6 times 2 is 12. Then minus 3 is 9 here. A potato. Potato is launched vertically. A potato is launched vertically upwards with an initial velocity of 100 feet per second from a. What are these questions? At the top of at the top of an 85-foot building, the position of the potato relative to the ground after t seconds is given by s of t is minus 16t squared plus 100t plus 85. Okay, let's do the first one. Find the velocity of the potato after these two. So minus 32t plus 100. Now, after 0.5 seconds, I get minus 16 plus 100. And I need to use a calculator, which is 84. Next one, 5.75 minus 32 times 5.75 plus 100 is a, hold on, this is minus 84. Find the speed of the potato at wait, what do they mean after and at? Determine when the potato reaches its maximum height. For speed, is it both 84? Zero 0.5. I think, like, if it's going like this, speed would be this. The magnitude of this and velocity would be like directly down, I think. Okay, let's just do C. Maximum height is when when the velocity is 0. That means D is 3.125. Now what? Okay, it reaches maximum height at this time. A potato is launched vertically upwards. It doesn't go like this, it goes straight up with an initial velocity of 100 feet per second from aircraft from a potato gun. Find the acceleration of the potato at 0.5 and 1.5. So the acceleration is it a minus 32? It should be, acceleration should be constant. Determine how long the potato is in the air. I think that's when it's a minus. It's an 85 foot tall building when it reaches BCD. When is this? Basically minus 85. So minus 16 t squared plus 100 t plus 85. This should be 0 because the 85 should cancel out. T is equal to minus p plus minus b squared minus 4 times a times c upon bottom squared. Okay, I'm gonna be using my calculator for this. Or should I do it on Desmos? Okay, 16 times 4 is 64. Plus it with 100 square. Then root. Okay, so I can do plus or minus. Let's do plus. Then divided by 16 squared. I'm getting a very small number. Let's do minus instead. Hold on. I'll just do it on screen. Desmos. So minus 100 plus 100 squared plus 64. All that divided by 16 squared. Something isn't right here. Oh, the 85 and 85 wouldn't cancel out. That's my mistake. It got stuck. Plus 170. Now t is equal to minus p plus minus p squared minus 4 times a times c upon bottoms upon, what was it, minus b plus minus a squared minus 4 times a times c upon 2a. Was it 2a squared? Hold on. It's just 2a. This times um, how is that possible? Hold on. S of t is minus 16t squared plus 100t plus 85. S of t, S of 5 and 7, 5. 3.1 at 3.125 it should reach its maximum. Two four 1.25. Okay. Okay. 131. This is velocity. .39 seconds. What if it is correct? Let's do V of t is 16, so minus 32t plus 100. V of 1.39, 55.52. This is for the last one. 55.52. Is it really 1.39? Let me see. 157. 84 minus 84. B 84. Is it 84 for both? C 25/8. Okay. D minus 32. Yeah, I said that the acceleration is constant. In both cases, E is 1/8. E is, what is this? 25 times root 965. It's 25 plus. And then F is this. It says 7 seconds. How did it get that? 1/8. 7 seconds. Do I have the quadratic formula right? Qua minus b plus minus b squared minus 4 times a times c upon 2a minus 85 hold on, this position is related to the ground, right? So we are actually finding 0. Hope I'm right. So this would be 85. Then this would be 85. Then that means this would be 85. Huh. Oh, minus. But one more thing. Yeah, never mind. Should I go to the next chapter? Let's do this one. $161. A. Find the price paid in dollars and the demand X for a certain digital clock is given by the plasma function P is 10 minus 0.001x. Find the revenue function. How do I find the revenue? Okay, never mind this. I don't understand business stuff. Should I go to the next question? Trigonometric functions. Okay. Derivative of sine and cosine. So, if I write them here, derivative of sine x is cos x, and then for cos it's minus sine. I have them all written in my website. If you guys want to check out the proof. Of tan, I forgot what tan x is. Let's do this question first. Five x cubed sine x. So then the derivative of the first times the second plus the first times the derivative of the second. Oh, it's an exercise. Let's do it then. So tan theta is sine, tan is sine over cos. So low d high I'll just write CNS. Low d high minus high d low upon bottom squared. And then minus derivative of cos is minus sine. Then bottom squared. This is 1 over cosine squared, which I think is secant squared. I think. I am not sure. Yeah. Find the derivative of cotangent. I think it would be the same process. So secant squared x minus cosecant. So for tangent and cotangent, secant and minus cosecant squared. For secant, it's sectan. For cosec, it's cosec cotan minus cosec cotan. Let me see if I can do it. Tangent and cotangent are related, so their derivative would be similar. Secant cosecant squared. And then secant sectan then cosecant is minus cosecant, cotangent. Let's say. Okay, let's do this one. Um, so the derivative is the derivative of the first. No, for this one. Derivative of cosecant. I mean, it's written right there. Minus cosecant x cotangent x. Now, derivative of the first times the second plus the first times the derivative of the second, which is secant squared. Okay, higher order derivatives. At the fourth power, it's still sine. The eighth power, it's still sine. For sine x, the derivative is the same for n. And for cos x, the derivative, it would be the derivative of sine x and repeat it for n plus 1 times. I don't know what I'm saying. Why is sine x? Hold on. Derivative of sine x. Let's do f of x is sine x. So derivative is, first derivative is cos x. Second derivative is minus sine x. Third derivative would be minus cos x. Then fourth would be sine. So what's the 59th? 59th. Let's do this. Cos minus sine minus cos, then sine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. So we are finding the 59th. I think it's minus cos. So 1, 2, 3, 4. Did we sine? At 56. Because 56 is divisible by 4, it would still be sine. 57, 58, 59. this checkpoint. Let's do the questions. Don't know if you guys can see. I'll just make it bigger. So I will write f of x for all of them. I have to find only the first derivative. Okay. So 2x minus sec x tan x and then that's it. Derivative of the first times the second cotangent, so minus cosec squared plus the first, no, whoops, let's do it like this. Can't remember this though. Minus cosecant square. Low d high minus high d low upon bottom squared. Hope that this is correct. Okay. Again, low d high minus high d low or the derivative of 1 is 0, so secant squared, so it will be cosecant. The minus will cancel out. No, wait. Derivative of tan. Wait, hold on. Minus sec tan. 1 bottom squared. I think there is a way to simplify this, but I don't want to do it. Next one. 183. This is the actual zone. 183. Low D high. Low D high. Derivative of cotangent is minus cosec. So minus minus cancel. Low D high minus high D low. Again. Wait. Low D high minus high D low. Bottom squared. Let's see. 77. 2x cot x. Okay, that's correct. 179. I didn't simplify it. I think it's supposed to be like this. 181. 183. 185. Let's simplify 181. So x, let's just make sure it's correct. Derivative of the first. Yeah, why does it say sec? Oh, actually, I accidentally did 182. So scratch this. What's 183? Is that correct? Okay, I'm not simplifying that. Let's do 181. Derivative of the first. So 1 minus sine x times the second. 1 minus sine x again. So the squared. Plus the first times the derivative of the second. Derivative of sine x is cos x. This would be minus cos x. minus x cos x minus square x. Should I simplify further? Nope. I think this is enough. X, y. Hold on. Cos x. Okay, never mind. Next one. The following exercises, find the second derivative. Okay, let's do 3 of these. Let's make this 100%. Now, so 191 the derivative of the first times the second plus the first times the derivative of the second then this is minus sign. So the second derivative would be, this would be 2 sine 2, hold on. Okay, this is going to be a little more complicated. Derivative of the first times the second plus the first times derivative of second. Okay. So the first derivative is 2 sine x if I'm right. Then cos, let's it with derivative of the first times the second derivative of the first times the second plus the first. Made a mistake. This is the answer. This and this will add, so 3 cos x. Next one. So the first derivative is, so x would cancel, and then the second derivative would be half sine. Next one, 195 cosecant. The 2 cosecant. So that's minus cosecant cotangent. And then minus 2 derivative of the first times the second. This would be square plus the first valuatory minus the first times derivative of the second, which I forgot what it is, cotangent cosecant squared, I think. So this would be cubed. This would be plus, if I remember correctly. Cot, yeah, cosecant. Let's see the answer. 3 yeah, 3 cos x minus x sin x. And 193 half sin x. 195 minus 2. There is no, hold on. 2 cosecant x. Okay, so cos x is out. You're left with cot squared and cosecant squared. But why is there no minus? Cosecant. Derivative of cosecant is minus cosecant and cotangent. Then the derivative of the first. This would be minus. I took the minus out over here, and for this one, it's minus cosecant and cotangent, and then times it by cotangent plus cosecant. Wait, cosecant times it by the derivative of cotangent. Just this is minus. So minus from here and minus from here will. Oh, I took the minus out. Yeah, and then it makes sense. But this one, 3 will remain. The first derivative is minus sine. Second derivative is minus cos. Third derivative is sine. So it's 3 sine. Yeah. Should I do the next one? I think I'll do that next stream. Okay, then. See you next time, I guess.